Hey guys, how's it going? I'm back here with another video, and this is the second video of the series where I teach you guys how to make a password manager using React, Node, and MySQL. So in the last video we set up everything. We're now able to, in React, submit a password to our kind of like password manager. We can add like a title to refer to that password, so like it's a password from a Facebook account, something like that. And if we go to our database, if we submit this, you'll see that in our database we already have two passwords right here that we use to test. But in this video we're just going to delete them because we're actually not going to store our passwords in our database like this. So you can see right now we're storing, like, I wrote password 123 in my front end, and in our database it says password 123. However, we don't want that for many reasons. The main one is that security. You never want to store passwords without, like, purely with the name directly, because that's completely insecure. What you want to do is basically you want to, in some way or another, encrypt or hash the password. So that's exactly what the point of our project, right? In this video I'm going to be teaching you guys how to basically use Crypto, which is a module that already comes with Node.js when you have it in your application, and it basically allows you to encrypt every single, like, use different encryption algorithms that already exist in the module to encrypt text and be able to decrypt it as well. So basically, we're going to be doing that for this video. So I just erased everything there and now it's fine. So how do we actually encrypt the passwords that we received? So you can see right now we're receiving the password from our front end, like the pure password, whatever the user enters here, in the app.post add password. So in this route right here, we're receiving the password as a variable like this. So what we want to do is, first of all, create a separate file just for working with this encryption, right? So I'm going to come over here and call this encryption. I'll just actually do it like this: encryption handler .js, something like this, right? And over here, it's going to be very simple. We're going to, inside of here, write two functions, which one is for encrypting a text and the other one is for decrypting a text, and then we're going to access those functions in our index.js. So we just want to, it's a bit of code, like it's a portion of code, so I don't want to write everything and like make this kind of messy, so I'm just opening it up in a different file. So over here, the first thing we got to do is we got to just calmly import the crypto library. So crypto, just as I mentioned, you don't need to install anything. It already comes with Node. So crypto, this one right here. And don't be confused by bcrypt. Bcrypt is it's an external module which you need to install if you want to hash things. And by the way, this video, I hope that you guys basically in this video also learn the difference between hashing and encryption, and I'll explain to you guys as we go into the video. So basically we just required crypto, and for now let's create the two functions. So the first one is going to be a function to encrypt, so const encrypt, and obviously in this function we have to pass an argument, which is going to be the text that we want to encrypt. So password, it's going to be the password that we want to encrypt, right? And then we also want to create a function called decrypt. So decrypt. And this is going to decrypt whatever password we want to have. And instead of passing here password, we're going to write encrypted password. Or encryption. Yeah, let me just say encryption, which is a lot smaller. So these are the two functions we want. And at the bottom, if we want to access those functions in another file, so in the index.js, we can just say module.exports and pass both encrypt and decrypt like this. So decrypt. Okay. And now if we want to access those files over here, what we can do is in our index.js, we can just come at the top here and let me just put some space, say something like const and say equal to require, and we're going to require where our file is, so /encryption handler, and now we can just access both functions, so encrypt and decrypt. Since we're exporting them over here as an object, we're passing an object with containing the two functions, we can just access it and destructure it like this. So we have access to the encrypt function and the decrypt function in this file. So how do we actually write those two functions, right? Because it doesn't come like that. The crypto module doesn't have an encryption function already built into it, because it doesn't really make sense since there's several different things that we need to account for, and I'm going to show you guys exactly how to do that. The first thing we need to account for is a secret. So I'm not going to be super secretive here. Basically, you have to create a secret variable which is going to basically keep your encryption safe. I'm just going to call mine I don't know, like, let me see, secret. I'm just going to create a variable called secret, and I'm going to just write the letter P 32 times. So that's something important for this algorithm. Your secret has to be 32 characters long. So I'm just going to write P 32 times, and it shouldn't like cause any issues. This is just for myself, but we need to be secure, right? So I'm going to write P, I don't know, 8 times, so 1, 2, 3, 4, 5, 6, 7, 8, and I'm just gonna paste it 3 more times. I hope that's 32, right? So now that we did that, the only thing we have to do is we gotta come here into our encrypt function, and we gotta start working through our encryption. So when you're working with encryption, there's something called an IV, which is kind of like an identifier to your encryption, and every different encryption has to have an IV. So we're actually, whenever we're going to decrypt something, we have to pass an IV as well, and it will become clearer as we go into the video. So we can just say const IV equal to buffer. So we're creating a buffer from basically just a bunch of different bytes. So what I mean by this is our encryption will be 16 bytes, so 16 characters, whatever you want to identify it with, and we can just do it by simply saying random bytes and passing 16. So it's just going to generate a buffer with 16 random bytes, which is just going to be our identifier. So for each encryption we need an identifier, right? And this will just randomize it so that we don't have the same one for like every time. And right here after this, what we have to do is we need to create our cipher. So a cipher is where everything starts to happen. What do I mean by that? Well, basically here's where we're actually going to encrypt our password. So let's create a cipher variable very simply by saying const cipher, and we're gonna set it equal to crypto. So crypto, and there's a function called create cipher from IV, or create cipher IV, IV. And over here we have to pass 3 arguments. So I'm just gonna lay out to you what arguments we have to pass to this function to actually create the cipher. Well, the first one is the kind of encryption algorithm. So there's many different kinds of encryption algorithms out there, and you don't need to worry, honestly. You just need to choose one. Just choose whatever. Like, I don't want to make this complicated, and you shouldn't as well. Like, you shouldn't. Like, if you're not gonna work with this kind of stuff, then don't worry that much. I'm gonna use one called AES256 CTR. So this is the one I'm going to use. If you want to use this one, then I recommend using this one as well. But you can use other ones that exist as well. You can check out in the crypto module documentation. And after, what you have to pass here is basically we have to turn our secret into a buffer. And we can do that very simply by just coming over here and saying buffer from the secret variable. So we're just transforming it into a buffer. And after this, we can just pass the IV. So those are the 3 different arguments that we want. So let me press enter here so you guys can see. Basically, we just want the first argument is the algorithm. This is the algorithm we're going to use. Then we're going to need to transform our secret into a buffer and pass that. And then we're going to pass the identifier to create our cipher. So now that that's done, let me just put that back in. I just wanted to show you guys. I'm just going to open this for now because we're not going to work on the browser for now. But after creating the cipher, here's where a lot of people get lost, but I'll just try to explain it to the best of my ability. So basically, we have to finally create a variable called encrypted password. So this right here is where this cipher right here is where we generate what will encrypt our password, and encrypted password will be the result of that encryption. So basically, what we have to do is we need to create a buffer that is going to concatenate both the encrypted password. So let me just say buffer.concat and just pass here an array just to define it. And inside of here, we're going to pass 2 arguments. The first one is going to be the encrypted the value to encrypt the password. So we can say cipher. We can use a cipher to update the password to its encrypted version. So password. And then what we can do is basically we can pass the end of the cipher. So this is kind of complicated, but basically we have to do this or else it won't identify it perfectly. So we have to say cipher.final and then just pass it like this. So this should be fine. This is the only thing we have to do, and this is the result of that encrypted password. So if you pass password over here, then encrypted password will be a variable holding the hash value for that encryption, right? So at the bottom here, the only thing we have to do now is you imagine we have to return encrypted password, right? Let me write encrypted password. However, this isn't true. We don't like this isn't exactly what we have to return. The reason for that is because first of all, as you can see right now, encrypted password is a buffer. And if you don't know about buffers, I recommend watching a very simple video, like a very simple video explaining it. You can understand it in like 1 or 2 minutes. I know it might seem a bit complicated if you've never heard of it before, but just watch a very simple video. I can even make a video about it if you guys want. So basically, it is a buffer, and you need to transform it into a string. So we have to pass the toString function, right? However, we also need to pass which kind of string, so basically which kind of encoding, as you can see right here, which kind of buffer encoding. We're going to use hexadecimal just so that it's kind of like numbers and characters. It's a combination of numbers and characters. We're just transforming it into hexadecimal. And now you might be wondering, well, then is this it? Not yet, because right here, will return the encrypted version. This is correct. This over here will return a hashed value that is encrypted. However, in order to decrypt, we can't just pass the password that is hashed and it will return a different value. Why? Because then that would be too easy, that would be too insecure. What we do is not only we pass the hash value, but we also pass the IV, the identifier. So we need to make it so that we need to set ourselves up so that when we call the decrypt function, we save both the IV and the password. So let's do that right now. Instead of just returning the encrypted password, we're going to return an object which is going to contain both the password and the IV. So first of all, let's return the IV. IV equals IV, and then password equals to encrypted password. Now we're returning an object containing both of this information. And the IV, as you remember, is a buffer, just like the encrypted password was. So we still need to do the same thing like we did before. We need to convert it into hex. I'm just going to copy this and paste it over here. So IV toString hex. So that's fine. We just returned it. And what do we have to do now? Well, we now have to write our decryption function. Well, to decrypt, it will be kind of similar, but with some small changes. The first thing we need to do is basically we need to create our decipher instead of a cipher. So decipher. And remember that encryption will be an object, will be this right here. This is what we're going to pass when we call the decrypt function, right? So we need to create a decipher and set it equal to crypto.create decipher like we did before from IV. So decipher IV. And similar to what we did above, we have to pass the exact same things. We got to pass the algorithm, the secret, and the IV. So we're just going to do it like this. However, as clear, like as I mentioned before, this IV exists inside of the encrypt password, the encrypt function. So what we got to do is we got to access the IV that we sent from the encrypt function. So over here we have encrypt. We're passing an object, and we're going to pass this as an argument. So in order to show the IV, we can just say something like a buffer.from, and then we got to pass the encryption, which is the argument from this function, dot IV. So we're grabbing the IV that we had from the encryption, and we also need to say that we want to transform it into hex. So this is the basic idea. We're just transforming it back into a buffer from the hex value that we had previously. So that's literally what we're doing. So we convert it to hex here, and now when we are decrypting, we're kind of like unconverting it. We're converting it back to buffer. So what we need to do now is we need to create a variable called decrypted, which will be the final version for our password, decrypted password. And it's going to be equal very similarly to what we had before. So let's do that as we mentioned. So let's just copy this right here, buffer.concat, and we're just going to set it equal to this. Then instead of being cipher, will be decipher, as you can see. and instead of being password, what we're going to do is we're going to say buffer from, just like we did before, we're going to convert our password that we sent from the encryption object into a buffer. So we're going to say buffer from encryption dot password, because we have the password property over here. So encryption dot password, and we want to say that we want to get it and transform it into hex. So that's nice, and we're going to keep this as well. We're going to decipher final, and now the only thing we need to do is just return this decrypted password, I don't know, like decrypted password dot toString, and transform it into, actually we don't need to transform it into anything. This will already do it for us. So this is perfectly, we now have the value over here, and we are returning the decrypted password. So this is literally it for all the complicated encryption stuff. Basically, we now have a function which is able to encrypt any text that we put, and then we have a function which is able to decrypt any text that we receive. So what do we do with this? Well, now we're going to come here to our index.js, and we can access both of these functions over here. And in our app.post, before we insert our password, we want to encrypt that password. So we can say something like const, I don't know, encrypted pass. I'm gonna call it hashed password. I know that won't be completely true, but I'm gonna say hashed password equals to encrypt, and we're gonna pass the password here. So that's basically what we're doing. We're encrypting the password before inserting it, and then after that's done, we're going to basically just, actually, we're just going to insert it directly here. However, we have to account for one thing. Remember, if we want to decrypt the password, we need to have the IV as well. And password, this right here, hashed password, won't return the password, like the string, the password string that is encrypted. It will return an object containing the identifier and the password. So what we have to do is we need to add another column to our table, which is going to be the IV. For each password, there's going to be an IV. So I'm going to come over here to our table and say something like alter table. And then the only thing we're going to do is we're going to add an IV for each password. And we're going to increase the size as well. I'm going to increase this to 255 because I don't know exactly how long will they. It's going to be 16, right? Yeah, but I'm just going to pass this right here and click on the not null, then click on apply. And as you can see, the SQL statement was completed. And now if we refresh this, we have an IV column, which means that now instead of just passing password title, we're going to pass password title and IV. And we need to also add another question mark here because we're going to pass a third variable. And basically what we're going to do is we're going to pass first of all, the hashed password dot password, because password will be the value for the password, and for the IV we're going to pass the hashed password dot IV. So that's perfect. We're going to pass both the IV and the password, and we're going to contain those in our table. So let's test to see if that's working. You can see we have our server running and everything. We don't have anything in our database. Let's try to add a password over here to our database. So I'm going to write a password like password 123 and let's say that it's my, I don't know, LinkedIn password. I'm going to click on add password. Let's check our database to see what happens. And you can see that perfectly now in our database, it includes a hashed version of password 1234, and we contain like the title, LinkedIn, and there's also the IV beautifully written over here. We're able to use that IV. So what do we do now? Well, now we have to manage a way to decrypt, like show the decrypted version in our frontend. That's the whole point, right? We're gonna show over here. We're gonna have when you enter into this website, there's gonna be a list of all your passwords, and if you want to see, like it won't show the passwords, but when you click on them, like on a button saying show password, it's going to decrypt the values from the backend, and it's going to show the raw version of that specific password. So that's what we're going to do. So yeah, I don't want to make this video too long, but I think this will be a 3-video series, so probably we're going to finish everything in the next video. So yeah, I really hope you guys enjoyed this video. If you enjoyed it, please leave a like down below. Comment what you want to see next. Also comment if you have any questions. I know we talked about some hard stuff. The crypto module is really weird in the beginning, but if you have any questions about like exactly, don't worry. If you have like literally, the important thing about programming the fundamental thing is whenever you see a word that you don't understand, like, or a function that you don't understand, or a piece of code that you don't understand, seek out for help. So like, if you didn't understand what I did here, let me know. I'll explain to you. Let me know if you have any questions. So yeah, really hope you guys enjoyed this video. If you enjoyed it, please leave a like and comment down below. Subscribe because I'm posting every single day, and I see you guys next time.